Hello everybody, this is Bahman Aras, the corresponding author of the accepted paper about software module clustering. The name of the proposed method is Sava. First of all, I should state the context of this study. The context of this study is related to software maintenance. Software maintenance is a process of modifying software, and at the same time about 60% of software costs are spent for maintaining it. In fact, software maintenance is an expensive steps of software development, and on the other hand, the cost of software maintenance depends on program understandability. What is the problem of this research? Software module clustering as a reverse engineering that can be used for understandable software structural model. Finding the best cluster is an optimization problem in the software engineering, and at the same time is NP complete problem. The main motivations of this study are as follows. The local optimum as the main drawbacks of the previously published paper about the software module clustering. The other demerits of the existing methods is inefficient performance and late convergence. The convergence speed is the other evaluation criteria of software module clustering methods. Instability and low success rate is the other drawbacks of the previously proposed method for software module cluster. Uh, the main contributions of this study is proposing a multi-objective genetic algorithm for generating effective clusters of a program source code. At the same time, we developed and implement a free software tool as Savalan for generating uh, the clusters for a program source code modules. The implemented software tool can be freely used by the researchers and programmers. The method proposed in this study uh, uses a multi-objective genetic algorithm to generate clusters for the program source code. The proposed method includes four steps. At the first step, the input source code is analyzed, and in the second step, the module dependency graph is generated for the source code by the existing tools such as GraphViz or CalGraph. And in the third step, as the main step of this study, the effective clusters using multi-objective genetic algorithm are generated for the input program, and finally the generated clusters are evaluated regarding the cohesion, coupling, modularization criteria. An extensive series of experiments have been conducted for evaluating the proposed method using 14 standard benchmarks. The proposed method was implemented using JavaScript programming language in Node.js framework. At the first step, we compared the Savalan as the proposed method with the classic bunch tool. As you see in this slide, the Savalan outperformed the bunch regarding the MQ criteria. At the next step, we compared the results generated by the Savalan with the single objective heuristic algorithms such as genetic algorithm, PSO, SFLA, and hill climbing. The results confirm that the generated clusters by the proposed method have higher performance than the generated clusters by the GA, PSO, SFLA, and hill climbing. And finally, we compared the generated results of the proposed method with the similar multi-objective techniques. As you see, the proposed method outperformed the similar multi-objective techniques in terms of cohesion, coupling, and MQ. And finally, as I mentioned in the previous slides, we have implemented the proposed method as a free tool and uploaded it in the website. You can see the URL, the address of the website, and the programmers and the researchers can use this tool freely for module clustering. And for example, we show the output of the Savalon as a free tool for a standard bench. Thank you for your attention.